Here we have 4 to the power 3 divided by 4 to the power of 5. 4 to the power 3 means 3 4s with multiplication signs between them, divided by 5 4s with multiplication signs between them. And cancelling, we get 1 over 4 squared. Now, as we know from a previous video, there's another way of doing this same sum. Because the bases are the same, 4, we can subtract the powers when we're dividing. So we get 4 to the power of 3 minus 5, which is 4 to the power of minus 2. Both sums are the same, so therefore the answers are equal. So 1 over 4 to the power of 2 is equal to 4 to the power of minus 2. So we've got a negative power. Now let's practice some more. Pause the video and see if you can work out the answer to this. Did you get that? 2 to the power minus 3. 1 over 2 to the power of plus 3 is also a correct answer. Now this time the question says, write as 5 to the power of n, where n is an element of a set of integers. And remember, integers are positive and negative whole numbers. So this time I've only got one possible answer. Pause the video and see if you can work out what that answer is. So it's 5 to the power minus 6. Note this time to write the answer 1 over 5 to the power 6 would be wrong because the base would be 1/5 and not 5. Now we're taking the base to be a variable. So we've x to the power of 4 divided by x to the power 6. I'm asked to write it as x to the power of n, where n is an integer. Pause the video and see if you can work it out. Now let's take a challenge. Pause the video to see if you can find out what the answer to this sum is. The answer is x to the power of plus 2. Now let's just have a think about that. When we're dividing, we can only divide if the bases are the same. So 1 isn't the same base as x. So from a previous video, I saw that x to the power of 0 is equal to 1. So I'm going to rewrite that 1 as x to the power of 0. The bases are both x. So I'm dividing, so I subtract my powers. So it's x to the power of 0 minus minus 2, which is x to the power of plus 2. Let's look at something else. If in our sum we're asked to make the powers positive, that could be written as elements of natural numbers because they're all positive. To make them positive, I bring the denominator up to the numerator and change its power. I bring the numerator down to the denominator and change its power. This is called getting the reciprocal of the fraction. Some people just say flip the fraction. When you want to make a power positive, you change it from the numerator to the denominator or vice versa. Now I'm going to ask you to pause the video and try and work this one out. That is, leave all the powers positive. Did you get that challenge? Well, let's see if you didn't. So on the top, I've got x to the power of plus 2, and on the bottom, I've got x to the power of minus 2. Dividing, subtract the indices. It's 2 minus minus 2. On the bottom, I've got a to the power of plus 3. On the top, I've got a to the power of minus 4. I'm going to bring that down. In other words, I'm going to be dividing. So it's minus 4. That's equal to x to the power of minus is plus, because it really means minus 1 times. So it's 2 plus 2 over a to the power of 3 minus 1 times minus 4 is plus 4. And there I get my result. Pause the video and try this division sum. I hope you got that one. Don't forget that we've got 6 divided by 3, which is 2. So we're just dividing the coefficients, these constants, and then dividing bases that are the same, subtract the indices. So 2 minus the 1 there, because that's our default value, is a to the power of 1. You can write in the 1 if you like. And another pair of bases the same. So it's b to the power of 4 minus 2, which is 4 plus 2, which is 6. Well done if you got that one correct.